Hello, this is my final project for CIDS Intro to Physical Computing, and what my device that I made for my final project pretty much is a thermometer that displays the temperature in Celsius and uses that temperature, which it gets from the sensor here, to run a fan with a DC motor. So more specifically, how it works is, so we have the Arduino Uno here connected to a prototyping shield, so we have more functionality with it. With that, we have this DHT11 temperature and humidity sensor provided in the Arduino kit. And basically what that does for this is it reads the temperature and the humidity, and after it reads the temperature and humidity, the Uno will display it on the LCD screen. So we have the sensor here is connected to digital pin 2 for this, so it can send data to that. Then the other two pins being connected to power and ground, so it stays powered. Next component of this is the LCD screen, and the LCD screen connects the or displays the temperature and the humidity of the device. And in order to get this done, it's pretty similar to what we did in some of the assignments, where we kind of bring like power to power and then ground to ground, and then some of these digital pins here just to data pins on the Uno, so it can read data and send it to and back and forth. One modification I did make though is for, I think in the assignments, we use things like a potentiometer to measure as like a voltage splitter for the contrast for this, but instead I just use a 220 ohm resistor and a wire going to power, and then the resistor going to power, and then just the wire going to ground to split the voltage. So it operates at a fixed contrast all the time. Yeah, and then the original part of the project that I derived this project from, that is pretty much it. It's pretty simple, just take a thermometer device and display it with an LCD screen. So what I added to the project was the fan with the DC motor. And basically what the fan does, it'll run at a certain operating speed based off what the temperature is. So right now it's 23.9 or 8 degrees Celsius. And so it'll run a little bit faster, but how does it run though, you might ask? So first off, we have, again, this is kind of similar to what we did originally. We have the motor hooked up to two different points here on the breadboard, and then one being ground, the other being power. We use the flyback diode between those two cables just to prevent voltage going where it shouldn't be. And then part of that voltage going to power, and then another part of the voltage going to ground. Then we use a transistor, so we were able to control the speed of the fan. And by doing that, we kind of similar again. So the base of the transistor goes through resistor, which goes to a pulse width modulation compatible port on the Uno. I think we're using 3 for this project on the Uno. And basically that allows you to change the speed. And then another part of it just going to ground. One issue though that I also added later on, kind of in between developing this, is I realized the Uno itself does not give enough power to power the LCD display and the motor. So what I had to do was take a 9-volt battery and this power supply and connect them kind of to the circuit here with the DC motor in order to give it sufficient power, especially the DC motor, which can be pretty demanding. So 9-volt battery. So for this one, this is powered mostly exclusively by the 9-volt battery at the power supply. I think the power supply gives it 5 volts and allows it to have its own 5 volts. Another nice feature using this power supply is it has this button right here, so it allows you to control when you want to turn the fan on and off. So now it's on when I press the button, and this is green, so it should be powered. And the fan turns on, and press 1 to turn back off. On, then turn it back off. So yeah, that pretty much shows you the fan and stuff working, and again, it'll be faster or slower based off the temperature. It is kind of warm outside right now. I think it's 66 degrees, so, and I have my window open, so it is a little bit warm in here. So the thermometer is reading a higher temperature right now, so it is running faster. So it is running faster. But if we did this in like a day in January or something, or I put this in like a freezer or maybe like a refrigerated area or just a cooler area in general, it would run much slower, or maybe not even at all, because we don't need the fan to be running if it's cold. I guess some other things I wanted to do with this project I didn't get time to is I'd love to kind of not have to use the breadboard for a lot of the connections. The issue is why I couldn't really do it with this project is I need female to female jumper wires for kind of connection with the LCD display, connecting to a resistor, and then connecting it to the Uno. Can't really do that with just the female and to male end jumper wires that the kit provides you, so I had to keep using the breadboard. Another thing I wanted to do, but I sadly didn't have time just because of other finals and just learning processes. I would love to make a 3D printed case for this. As I know from class, you can use forgot the app's called, but you can like use an app, convert it to G-code, and then using like an SD card or a micro SD card or USB depending on 3D printer, plug it into the 3D printer and it'll print out a case for you. So yeah, we didn't really have a big enough 3D printer for my case, and I couldn't get the one in ACM. Maybe next year, but not really relevant. I do have a case design here though. So as you can see, I have a case here. This is supposed to be a hole, which will allow the fan to go through, and then just a hole in the back to allow air to flow through the case. And then this is a little hole for the temperature and humidity sensor, as we have right here, so it can read temperatures better. And then another hole for the LCD display, which is displayed right here. And then again, another reason why I really can't get the case to work right now, sadly, is just I would need to use the breadboard right now, and I don't have female wires, so it's just not ideal. But definitely something I'd like to do in the future. If I find time this summer, I may modify this even more to make it a more complete product. Yeah, apart from that, that is my project. It went from just being like a simple thermometer that just reads temperatures to becoming a fan, kind of almost like an air conditioning unit with its own thermostat, where it can or it's even its own humidity control module with a fan that changes speed based on how warm or cold it is, or how humid it is. Well, anyways, thank you for your time, and have a good one.